Good evening, class. Let's continue with the topic. Okay. So today we'll be doing electron gain enthalpy. Electron gain enthalpy. Now, what is the meaning of electron gain enthalpy? It means enthalpy means energy. It means the energy change when an electron is added to a neutral isolated gaseous atom. Okay, it represents energy change when an electron is added to a neutral isolated gaseous atom. Okay, now why we are saying the word energy change? Represents energy change. Now why energy change we are mentioning? Because the energy change might be positive, maybe positive or negative. Means in some cases energy might be released. When energy is released, the energy change is negative. This is when energy is liberated. But for some elements, instead of releasing energy, energy is absorbed. So in that case, your electron gain enthalpy values are positive. So basically, electron gain enthalpy represents energy change when an electron is added to a neutral isolated gaseous atom. You can also define it as the energy that is released when an electron is added to a neutral isolated gaseous atom. That is also correct. But you need to know that basically it is the energy change. In some cases, the energy change will be positive. That means energy will be required. And in some cases, energy will be negative when energy will be released when an electron is added. That you need to know. Factors affecting electron gain enthalpy. First one is your nuclear charge. Nuclear charge. So, what happens when the nuclear charge increases? As the nuclear charge increases, the nuclear pull on the outermost electrons will be more. As the nuclear charge increases, the nuclear pull on the outermost electron will be more. As a result, the incoming electron means the electron that to be added to that atom. Incoming electron will feel more attraction. So, electron gain enthalpy values. So, electron gain enthalpy values are highly negative. Enthalpy it's highly negative. Okay, when the nuclear charge increases, the nuclear pull on the incoming electron that is to be added to the atom will be more. As a result, electron gain enthalpy will be highly negative. Right? A second factor is atomic size. Atomic size. If atomic size increases, when atomic size increases, distance between the nucleus and the outermost shell will be lesser. As a result, the incoming electron, because incoming electron will be added to the last shell only. Right? So if the size is more, distance between the nucleus and the last shell is more. As a result, the incoming electron will suffer less attraction. So the values will be less negative. When the nuclear charge is more, nuclear pull is more on the incoming electron, so values are highly negative. When atomic size is more, nuclear pull on the incoming electron is lesser. As a result, your electron gain enthalpy values are less negative. Now, last factor is electronic configuration. This we spoke in the last class also. There are certain configurations, basically half fill, full fill configurations, which are highly stable. So they are reluctant to either loss or gain of electrons. So same thing will be applied here also. Configurations like NS2, configurations like NS2 NP3 or NS2 NP6. These configurations, they will be highly reluctant to accept any electron. So basically for this configuration, the elements that have this configurations, they will either have highly positive electron gain enthalpy values or zero enthalpy values, or zero electron gain enthalpy values. Either positive or zero electron gain enthalpy, because they will be reluctant to gain an electron. Okay, so these are the few factors. Now the next one is your successive electron gain enthalpy. Successive means what? One by one. Successive, last class when we did ionization potential, that time also did. Okay, so successive means basically one by one. Successive electron gain enthalpy. So successive electron gain enthalpy means for elements where there is scope to add more than one electron, that time we can apply successive electron gain enthalpy. For example, if I talk about halogens, what is the configuration? Halogens for say for example F, what is the configuration? It is 2s2 2p5. So it can have only one electron gain enthalpy value because P can accommodate maximum 6. So it can accept only one electron, not more than that. Halogens can accept only one electron. So for halogens, this successive value does not apply. But if I talk about group 16 elements, for example oxygen, it's 2s2 2p4. So it can accept 2 electrons, right? Obviously one by one. So for this kind of elements where there is scope to add more number of electrons, basically successive electron gain enthalpies applies to them, right? So here what happens, when we add one electron, it gets converted to O minus, and my configuration is 2s2 2p5, right? Second one, again one electron because it has scope to add one more electron, and we get oxide and O2 negative. Now the problem is that in the first step, when one electron is added to oxygen atom, it readily accepts. So for converting O to O minus, my electron gain enthalpy value will be negative. Electron gain enthalpy value negative. Electron gain enthalpy negative means energy will be released. Enthalpy negative. That means energy will be released when O to O negative is formed. But in the second step, what happens? O negative gets converted to O2 minus. Means it is already a negative charge species, and to that negative charge species we are adding one electron, right? So it suffers from inter-electronic repulsion. This O minus and 1E negative, they will suffer from inter-electron repulsion. Now to overcome this repulsion, external energy has to be given. As a result, here what happens? Here the electron gain enthalpy values will be positive. Electron gain enthalpy value will be positive as some amount of energy is utilized to overcome the repulsion. So my second step energy will be required. First step energy will be released, so negative. Second step energy will be positive, right? So this is basically your successive electron gain enthalpy. Now last part, the periodic trend. Periodic trend means across a period and down a group variation we have to speak. Across a period what happens? Atomic size decreases. Your nuclear charge increases. So what happens? Nuclear pull on the incoming electron or the electron which is to be added will be more. As a result, the electron gain enthalpy will be highly negative. Electron gain enthalpy highly negative. Highly negative. Down a group what happens? Down a group, atomic size increases. Both atomic size and nuclear charge increases, but the effect of increase in atomic size is much more than the effect of increase in the nuclear charge, right? As a result, what happens? The incoming electron does not feel much nuclear attraction, due to which the electron gain enthalpy values down a group are less negative. Okay, so this is basically your electron gain enthalpy. Okay, thank you class.